Consider the parabola y square is equal to 4ax. Let s be the focus of the parabola and a pair of tangents drawn to the parabola from the point P, which is minus 2 comma 1. So let me firstly draw the diagram of parabola. It will be like this: y square is equal to 4ax. A here is 1. So focus will be 1 comma 0. Fine. And we have told that from minus 2 comma 1 we have pair of tangents drawn on the parabola. So let us take here the point P, which is minus 2 comma 1, and a pair of tangents are drawn from this side. You can see here, this is a tangent first and this is another tangent. Okay, so after that parabola meet at P1 and P2. So let us name it as P1 and P2, and after that let Q1 and Q2 be the points on the lines SP1 and SP2 respectively. So this is S, and if I join S with P1 and P2, then Q1 and Q2 are points lying in these lines, such as Q1 is lying on SP1 and Q2 is lying on SP2, such that PQ1 is perpendicular to SP1 and PQ2 is perpendicular to SP2. Okay, if I draw here a perpendicular which is here named as Q1, and another perpendicular which is named as Q2 is perpendicular to, then which of the following is slash R are true. So you have to check the options whether which option is correct or which option is wrong. So firstly we will check this SQ1 and SQ2 whether they are correct or not. So if we see that general equation general parametric coordinates of P1 will be like 80 square comma 280, and here actually A is 1. So this P1 will be turned as t square comma 2t. Fine. And as you know that parametric tangent means a tangent to the parabola in parametric form can be written as. So if I talk about parametric tangent passing through this point P1, it will be written as ty is equal to x plus at square. I'm not going through the proof of this equation, how this equation came. You can see it is easily available uh, every possible resources of mathematics. So we can see that this minus 2 comma 1 is line is in this equation. So we will be putting here minus 2 comma 1 in this equation, minus 2 comma 1. So after putting minus 2 comma 1, we will have here minus 2. A is 1, so this will be simply like this. Then after that t square minus t minus 2 is equal to 0. Fine. So this equation can be written as t uh, plus 1 into t minus 2 is equal to 0. So here we will have t is equal to 1 and minus 2. So here there are 2t, which is 1 and minus 2, and we can see that 80 square is also positive. If we put 1 in the place of t or minus 2 in the place of t, then it is not going to change its sign. So x will be positive here, and y will be changing as negative of t. So we can see that we have gotten our p1 and p2 coordinates, which are p1 will be uh, coordinates, and then since p1 is in first quadrant, so there both coordinates will be positive. So we will be putting here t is equal to 1 and a is also 1, so this will be 1 comma 2. Similarly, p2 is lying in the fourth quadrant where y will be negative, so this will be sorry, there will be minus 2 whole square, which will be 4. Fine. And 2a is 1, t is minus 2, so minus 4. Fine. So these two are coordinates for p1 and p2, and there will be t is equal to minus 1 and t is equal to plus 2. Okay, so there will be, and on putting minus 1 there will be 1 comma minus 2. Fine. So let me write here, this p2 point will be 1 comma minus 2, and this p1 point will be 4 comma 4. Okay, so what I will be doing here, we know that sp2 is the line on which pq2 is perpendicular and passing through minus 2 comma 1. So using I will be using writing the equation of sp2 and then writing the equation of pq2 and then finding the intersection point. So uh, let us take firstly sp1. So if I write here equation of sp1, then I will have the equation will look like y minus 4 and x minus 4. Y2 will be 0, 0 minus 4 upon 1 minus 4. Okay, so after that, simplifying this equation, we will have here minus 3y plus 12 is equal to minus 4x plus 16. Fine. So 4x minus 3y minus of 4 is equal to 0. This is equation of sp1. Fine. And if I write here perpendicular equation to this uh, line, then it will be minus 3x minus 4y bx minus ay is equal to lambda, and minus 3, and it is passing through minus 2 comma 1, so here x is minus 2 and minus 4 is comma 1, so here will be minus 3x minus 4y is equal to minus 6 minus 4 is equal to 2. So 3x plus 4y is equal to 2. So if I solve these both equation, I will have the point q1. So 4x minus 3y is equal to 4. 3x plus 4y is equal to 2. So let us solve this equation. Multiply this equation by 4 and multiply this equation by 3 and sum it. So 16 plus 9 will be 25x. 16 plus 6 will 4. 16 minus 6 will be 10. Here x will be 10 by 25, or it will be 2 by 5. So similarly, x is 2 by 25, 2 by 5, then y will be, you can calculate it by putting on any of the two equations. So you will find y value as minus 4 by 5. Okay, and now let us go for q2 point, and you can see here x coordinate is same. S has same x coordinate as of p2. So it is actually a straight line, and you can see it is a straight line, and it is perpendicular to x-axis because it is parallel to y. So you can say it is the equation which has you can simply write the equation of sp2 as sp2 as uh, x is equal to 1. So perpendicular to this equation will be y is equal to lambda. What is lambda here? And perpendicular and lambda means perpendicular equation will be passing through minus 2 comma 1. If you put here y is y value, y coordinate of this coordinate, then you will have here y is equal to 1. So finally your equation is equal to y is equal to 1 perpendicular, and q2 will be simply as 1 comma 1. Fine. So you can see here q1 is 2 comma 5 and minus 4 comma 5, and q2 is 1 comma 1. So one thing you can notice here that this point is lying in first quadrant, but uh, why it has ordinate as a negative quantity, and this is lying in the fourth quadrant, but it has both ordinate and abscissa as positive. So here let us make some calculations here. After that, whether we let us take some calculations here. We will assure something that this SPQ1 and SPQ2 are somewhat like a congruent triangle. This we can see that angle PQS2, you can see that angle PQS2, this angle is 90 degree, and similarly this angle is also 90 degree. This side is common. Fine. So let us check that whether SQ1 and SQ2 are equal or not. Okay, if they are equal, then the triangle is congruent. So let us see that whether the SQ1 and SQ2 are equal or not. Okay, so if you see SQ1, SQ2 is, you can see that simply it has a distance of 1 unit. Okay, and for SQ2, SQ1, you can see that you have 1 minus 2 by 5 whole square, uh, and 4 by 5. So you can see that uh, it will be 9 by 25, it will be 16 by 25, 25 by 25, it will also be 1. So both triangles are congruent. Q1 and Q2 can be interchanged with each other. So you can see that the question was confusing us, or just nothing more than that. This was the can be said that this was the twisted point of this question. So SQ2 and SQ1 are same and has a distance of 1 unit. So D option is correct. A option is wrong. If let us see this PQ1. So PQ1 will be distance, right here. PQ1 will be minus 2 by 5 whole square plus 1 plus 4 by 5 square. So it will be 10 plus 2, 12 by 5 square plus 9 by 5 square. So you can see 12 by 5 square and 9 by 5 square. So 1 by 5 will be outside, and under root of there will be 12, which will 144, plus this will be 81. 5, 2, 2. So inside there will be 15. The root will come out as 15 by 5, and which is equal to 3. So PQ1 is also correct. Similarly, you can see that Q1 and Q2 will also have 3 root 10 by 5 distance. You can simply calculate, we have coordinates here. So in this question there was just one single twisted point, that one student can get confused here, that why this coordinate is mismatching here, that Q1 is in first coordinate, so it is coming just like same as in it is in fourth quadrant, and Q2 is behaving like as it is present in first quadrant. So it was just like that both triangles were congruent, so SQ2 was equal to SQ1. So you can replace SQ1 and SQ2, and they have same, the triangles are almost same in angles as well as distance of the sides. So thank you and have a nice day, nice time ahead.